Okay, I'm going to get started on Chapter 10, Probabilistic Reasoning. It's really important to understand probabilistic reasoning if you're going to understand research, because research is entirely based on probability. So it's not necessarily a natural way for humans to think, but it's an important way for scientists to think. So let's get started with a dice game. Now, normally I like to do this in class, and I have my students log into Socrative and vote on how they think things are going to come out, but obviously we can't do that here. So I always like to think that maybe you guys would be intrigued by what you're seeing and might want to share it with the people around you. So maybe you could guess ahead of time, see if your guess is fulfilled, and then afterwards maybe show this, dice to people around you, your family or friends or whatever, and see if they make the same kind of conclusion that you made, and maybe it could be kind of fun. Anyway, so I always have these fantasies about you guys like passing information around to people. Anyway, so it's kind of a goofy looking dice because I was trying to make it using the shapes on PowerPoint, and so it came out looking a little incompletely made. So it's a folded dice apparently. And so you're seeing what we'll call the front, and it's red, and then its opponent side, we'll call the back, it's also red. And then the four sides around the circumference would be all green. So we got 4 green sides and 2 red sides on this dice, or on this die. All right, so here's the bet that you've been offered. Obviously an imaginary bet, because I'm not going to really give you anything if you're right. You'll just have the pleasure of knowing you were right. So you're offered a bet. You will be paid $25 of imaginary money if you correctly predict the sequence of colors rolled. So before anything gets rolled, you have to say which of these 2 sequences you think is going to happen. So which one is more likely? Which one would you bet on? Red, green, red, 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 or green, red, red, red. Which one do you think is more likely? If you want to pause and think about it for a second, I will just sit here and wait for you. No, I'll keep going. So which pattern is more likely? Now, like I said, I normally have my students in class log into an online voting place and they give their votes, because otherwise we get swayed by everybody else's opinion, right? So I wait a second, okay, what do you guys all pick? And we look at what their ranks were. And what we usually find is that more people vote for the second pattern. Green, red, red, red. That's the more popular choice. And I think it's based on, ratios. We have 4 sides that are green and 2 sides that are red. So our brains tell us, well, if there are, twice as many green sides as there are red sides, I would expect green to show up twice as often as I see red show up. So I like the sequence that contains the greens better, so I'm going to vote for that. Here's the thing. We're talking about betting. You need to know your probabilities, right? The probability of being correct on a sequence that only contains 5 rolls is higher than your probability of being correct on a sequence that contains 6 rolls. So if you notice the one on the left is 5 rolls, the one on the right is 6 rolls. So you should always go with the 5 rolls, especially when you notice that the one that has 5 rolls is a subset of the one that has 6 rolls. So you really should be picking the one on the left, because all you've done on the one on the right is add in a green. Our brains are not super fond of probabilities, and so when we look at the ratio of reds to greens, we say to ourselves, well, I will pick the one that has more of the color I expect, which is based on ratios, green. And we ignore the probability, which is the probability is higher that you'll be right if you only have to make 5 choices than if you have to make 6. Okay. Now we're going to talk about some of the things that make it likely that people will ignore probability. One of those things is what we call the prevalence of miracles. I'm going to pause for a second, and then I'll come right back. Okay, I'm back, and I apologize for what has got to be background noise, because I am in a room with a very noisy air conditioner on. Okay. So the prevalence of miracles is one of the things that contributes to our failure to recognize the probabilities of things. We oftentimes refer to these as person who statistics, because a lot of times when we hear about a person who had this happen to them or that happened to them, we make the mistake of thinking, oh, that outcome's probably likely, because look, it happened to this person I know, or who somebody I know knows. Let's talk about it a little bit. All right. This was contained in an email that was being circulated after 9/11, where they gave you a series of complicated instructions for folding the $20 bill into different patterns. Here you fold it lengthwise, then you fold it like you're going to make a paper airplane. And then when you place it next to a photograph of the Twin Towers burning, it does kind of look like the folding has created the appearance of the Twin Towers burning. And then you see this ominous, what are the odds that a simple geometric folding of the $20 bill would accidentally contain a representation of both terror attacks? It actually had a different fold that you could do to reveal the Pentagon. What are the probabilities? What are the odds? I'm going to say 100%. If you fold a $20 bill and then project onto it your memory of something that has recently happened, that you'll see that, right? Now, here we are 20-ish years away from 9/11, and we look at it, and we can look at it a little bit more objectively and realize it doesn't look that much like the Twin Towers burning, does it? It doesn't seem as ominous when it's not top of your mind. But it just happened at the time, and so it looked very much to people like that was a depiction of the Twin Towers burning. Here's another example of a person who statistic. Miracle recovery. Doctors said I'd never walk again. And then what I pulled from this article was that at the very end it says, she proved them wrong. So when doctors come in and tell you you have a 70% chance of being paralyzed, that does not mean that you're going to be paralyzed, does it? It means you have a 70% chance of being paralyzed. Doctors deal in probabilities all the time. Given 100 patients with this kind of accident, 70 of them end up paralyzed. So she proved them wrong, though, right? She was able to walk again. Well, she didn't prove them wrong. She proved that she's in the 30% instead of the 70%, or whatever statistic she had been offered. But we like hearing these miracle recoveries. We think that this person is now, in fact, the doctors are wrong, and that she is the more likely outcome. That if you just want it bad enough, you can make this outcome, which puts a lot of pressure on a patient, doesn't it? If you want it bad enough, oh, you must not have wanted it bad enough, right? What a horrible message to give to patients. But this is what people do with person who statistics. Breast cancer survivor delivers miracle baby. I basically just Googled miracle recoveries or miracle medical outcomes and found stories. What oftentimes happens with people who are treated for cancer is that they are told that their reproductive cells may not function correctly and that they may not be able to have children. So when she was able to have children, her baby's now a miracle baby. Well, doctors oftentimes tell us things so that we will be braced in case the worst occurs, because doctors know that there's a probability of a negative outcome. So they tell us, we have a probability of a negative outcome. A lot of times what patients hear is a doctor saying, you will not be able to have children. I can't tell you, I teach human sexuality, I cannot tell you how many women have told me that they have been told that they cannot have children. And when I question them more closely, they say, well, what the doctor said is that I've got endometriosis and the probability is really low. And what they hear is you can't have children. And when they do end up having children, they say, wow, it's a miracle. Probabilities. Brothers from another mother. What's the likelihood that you would find two species with the same exact fur pattern? Well, first off, based on this picture, I'll say 100% probability that you could find two creatures with the same fur pattern. Second off, my own memory tells me that I can, because I've seen goats with this pattern, I've seen dogs with this pattern, I've seen all sorts of creatures with this kind of pattern. And then the last comment I'd like to make is they're not exactly the same, are they? So I'd like to argue, sometimes if it's similar enough, we think it's an example of a miracle. Or we think that it's one of those more than a coincidences. Here's another picture that I got as an email. look at the magical crane hanging a moon. It's a magic trick. Wow. What are the odds? Well, every 28 days, I'd say it's going to do it again as long as the clouds aren't in front of it, right? A lot of times we focus in on what appears to us to be a rare occurrence, and it turns out it's not that rare of an occurrence. So let's take that thinking and let's apply it to psychological findings. Now, I intentionally tried to find psychological findings that ultimately, hopefully, everyone in the class will feel like, well, that can't be true because I'm in that group. So hopefully I'm going to hit everybody with my 3 examples. Here's one study that has actually been replicated quite a bit. Couples who live together before marriage are more likely to divorce. Okay, that's one finding for us. Girls raised by stepfathers start menarche earlier. That's having your first period. So girls who are raised by stepfathers, even when compared to their own sisters who reached menarche while mom and dad were still married, girls whose parents have divorced start menarche earlier than their sisters did. Okay. Boys who play violent video games are more aggressive. They've measured aggression a couple of different ways. One is by seeing how much Tabasco sauce they dole out to an imaginary partner that they think is a real person, or how loud they turn up white noise that's going to blast the ears of what luckily is an imaginary person, but that they think is a real competitor. It's not, they don't measure it through like, did they punch someone or something like that. They measure it through these aggressive acts that are designed to harm the other person. Okay, so hopefully I hit on something that you're like not completely buying this relationship. If you're feeling skeptical, then you're kind of showing that kind of person who's statistic thinking, where you're thinking to yourself, well, I'm living with my significant other, and we're completely happy, and I don't think we would ever get divorced if we got married, and you're thinking those thoughts. Or I lived with my significant other for years before we got married, and now we've been married for, 20 years. That has to be wrong. Or I was raised by a stepfather, and I started my period at the same time as everybody else did. I don't know what you're talking about, right? Or I play lots of violent video games, and I'm less violent than my siblings or my peers who don't play them, or whatever you're thinking, right? The thing I want you to remember is this reaction that we have, where we're like, that doesn't describe me, doesn't mean that the statistics that are being reported are not correct. All these things say are more likely, or start earlier, or are more aggressive, right? These are relative terms. This is not saying that a couple who lives together will get divorced. They are more likely than people who didn't live together to get divorced. And that doesn't mean that for any individual we know the likelihood of divorce. They actually followed couples using the census over 20 years to see whether there was actually a relationship between living together beforehand and divorcing. They don't know what's causing what or anything. All they can say is that the couples who went from cohabitation to marriage had a 10% higher chance of divorce than couples who got married and moved in together for the first time after the marriage. That's all we know. We don't know why. All we know is that there is a statistic. Now that I told you what the statistic is, though, 10% greater chance, you might be like, oh. And you should be thinking that. Oh, well, that's not really that much. So you go from a 28% chance of divorcing within 20 years if you don't live together to a 38% chance of divorcing within 20 years. So a lot of people think to themselves, oh, that's a lot different than I thought. Not quite as meaningful as it sounded. Girls raised by stepfathers start menarche earlier. It's measured in weeks. It's not measured in years. It's measured in weeks. So it's not, again, in the big scheme of things, probably even that big of a difference, but it is statistically different. And so it's something worth reporting. And if you look at entire groups, it looks like a trend. But for an individual, probably isn't even noticeable compared to their sisters or their peers. And then with the boys who play violent video games, they're talking about measuring the difference in the Tabasco sauce dose in milliliters, or the volume on the white noise in, a few decibels. So it's not like you go from people who don't play violent video games, they only play, the white noise at 65 decibels, the intensity that we have in a whisper. And the people who play violent video games, they're up at 240 decibels, the sound that you hear with a jet engine. No, it's not like that. It's measurably different, but maybe not meaningfully different for an individual's behavior. So keep that in mind. It's not necessarily a miracle when one individual behaves differently from the predicted pattern. Some of our thinking errors. This might take me a while, so I think I'll take a break here and come back and finish this up in another video.